So we're having more on rectangles. We're still on perimeters and areas of plane shapes. One of the sides of a rectangle measures 12 centimeters, while its diagonal is 13 centimeters. Calculate the area of the rectangle. Area of the rectangle? Well, let me quickly sketch this out. A rough sketch. Sorry. Uh-oh. There. There. We are told this is 12. One of the sides is 12. And that the diagonal is what? 13. So, and that's a diagonal. Let's say that is 13. We are to find the area of this rectangle. Area of the rectangle is the length of the rectangle times the breadth of the width. Of course, we expect this to be our breadth, and this is our length, 12. We do not have any information about the breadth. So what do? Rather, we are given the diagonal as 13. I can apply Pythagoras theorem here because it's a right angle. Right, and we have a right angle triangle there to obtain the side B. Since 13 will serve as the hypotenuse, I can say, okay, using Pythagoras. Why am I doing that? If I call this A, I call this B, I call this C, I call this D. You can see that triangle ABD is a right angle triangle. So I can apply Pythagoras there to obtain the side B so that I can come back and find my area, because right now I only know 12, which is the length. I have no information for B. So I'm going to have to look for B. So using Pythagoras, I say, okay, the hypotenuse square, that's 13 square, is equal to the sum of the squares of the adjacent sides. This is 12 square, and then what? B, the unknown side. This is 169, and here I have 144 plus B square. Of course, we play around a bit here. I have 169 minus 144. That will give me B square. That will give me B square as 25, but let's write this out a little bit here. Here. Let's just follow in there. So we stop here, actually. So from here, we have our B square as what? As 25. Our B is 5. Remember, we are looking for the area of the rectangle, which is length times breadth, and we have it as 12 times B. Now we have obtained B. Next is to find our area. So the area will be what? 12 times 5. And that will give us 60 centimeter square. That's splendid. So that's it there. Area is length times breadth, 12 times 5, which gives us 60. Next problem, our focus is on rectangles. The figure below represents a tiled rectangular room of dimension 3x and 2x. That's the exterior dimensions you can see there. The colored section is of uniform width, 2 centimeters, and has an area of 64 centimeters square. So the colored section is what? Has an area of 64 centimeter square. We are asked to find the value of x. We can simply look at the whole object as a large rectangle outside and an inner rectangle inside. From what we have here, if the length from this point to this point is 3x, then what will be the length from there to there? Of course, we have to subtract this 2 and subtract 2 this way, because we are told that the thickness of this is 2 centimeters. So this will now be 3x minus 4. That's 2 centimeters this way and 2 centimeters the other way. Likewise, the inner width will be 2x, also minus 4, that we will subtract 2 this way and 2 that way. Now if I can find the area of the inner rectangle and the area of the outer rectangle, the difference between the two will give me the area of the shaded portion or the colored region. So I can say area of big rectangle minus area of small rectangle will give us the area of what? This colored section, and we are told that is 64. Remember, the question says that the colored section is of uniform width and has an area of 64 centimeters square. Now what's the area of the big rectangle? That will be 3x by 2x, length times breadth. So we have 3x times, let me use bracket there, 2x minus the area of the small rectangle will be the length, which is 3x minus 4, and the width, which is 2x minus 4. So I have 3x minus 4 as the length times the width, 2x minus 4. And we are saying this is equal to what is given to us as 64. Let's open this. 3x times 2x will give me 6x squared. Let's cover this first. 3x times 2x again is 6x squared there. 3x times minus 4 will give me minus 12x. Minus 4 times 2x will give me minus 8x. And minus 4 times minus 4 will give me plus 16. I'll close that. That still gives me 64. Simplifying, I open this bracket here. I have 6x squared minus 6x squared. Take note of the minus sign. This will become plus 12x. This will become plus 8x minus 16 equal to 64. Yeah. Let's go to the next slide and see what we have there. So that's it, that the area of the colored part will be what? Area of large rectangle minus area of small rectangle, as we have just said. And you can see there that the length of the inner rectangle is 3x minus 4, and the length of the inner rectangle, the width of the inner rectangle is 2x minus 4. And where we have that the area of the large rectangle is what? 3x times 2x. Exactly what we did. And that's 6x squared. And the area of the small rectangle is what? The length times the width. And that gives 6x squared minus 20x plus 16. Now subtracting the small rectangle, area of the small rectangle from the large one. That's where we left off in the last slide. Now let's progress. That now gives us this 20x minus 16. And now rearranging, we have 16 moving to the left hand side. And we have 64 plus 16, which gives us 80 equals to 20x. And from there we obtain our x as what? 80 divided by 20, which is 4 centimeters. This is a composite shape, so to say. We have two rectangles, an outer one and an inner one. And most of the time the question will always require that you should subtract the area of the small rectangle or the inner rectangle from the outer rectangle, which is always of a greater size. That's it for this video clip. And I think that's it also for rectangles and parallelogram. We're moving to video clip 7.